You suck as a software engineer if you don't know how modern databases work. Everyone says modern databases like Aurora, Spanner, and DynamoDB are insanely fast. The interesting question is, how? Because they're not magically making disks faster. All right, let's start with the simplest database you'd build. You spin up one machine, the CPU runs your queries, and the same machine stores all your data on disk. That's exactly how traditional databases like MySQL or Postgres begin. This works fine at first. Then your application grows. More users arrive, queries get heavier, disks become busier, and suddenly one machine has to do two completely different jobs: process requests and store data. You have only one option: buy a bigger machine. Eventually, that stops being enough. This is where database architecture takes a completely different turn. Instead of scaling one giant server, engineers separate compute from storage. Now, the compute layer only worries about executing SQL queries. The storage layer focuses on safely storing and replicating data across multiple machines. Because they're independent, you can add more compute nodes without copying terabytes of data every time. If one compute node dies, another simply reconnects to the same storage layer and continues serving requests. Sounds perfect, until the network gets involved. Every read and write now has to travel between compute and storage. Every write also needs to be replicated across multiple storage nodes to keep your data safe. Without careful engineering, latency starts creeping in. That's the trade-off modern databases accept: a little more network complexity in exchange for virtually unlimited scalability and much higher availability. Takeaway? Modern databases became faster, not by building bigger servers, but by separating compute from storage, so each can scale independently.